Let's start. First week. First week is a bit, it's important week. It's a bit not so interesting. Why is that? Because we need to study notation. We need to prepare our common language to understand our course. So this lesson is a bit, theoretically, a bit basics, many notation here. If it's very easy for you, it's very good. If it's very hard for you, okay, it's not so bad, but it's not so good. Probably you need to review your material about discrete mathematics, about set notation. You will see, okay? So this is our dictionary. Today we'll talk about sets. We'll talk about sample space, about set, complement of sets, intersection of sets, union of sets, empty set, universal set, whole set, etc. Do you know this notation from previous courses, from today's lesson? You know it, okay.
Yeah.
Okay, let's start. Let's start something basic. Pay attention, it's not very interesting. It's not very important, but this exercise is important from pedagogical point of view. I want to explain you how we prove theorems, how we can use sets. So this question is not very interesting, but it's important. Okay. We want to prove, just a moment, I need to add my pen. Just a moment. Okay. It's here. Yes, annotation. Yes. Here we want to prove that this set equals to this set. Okay, why is that? We want to prove it. Pay attention. First of all, you can try to draw it. Suppose this is our sample space. This is set A, and this is set B. In this case, where here you can find A intersection B?
In the middle.
Yes, this is A intersection B. But we want complement of A intersection B. The complement is outside of this. So complement of A intersection B, it's all white spaces in omega. Okay, this is left side. What does it mean right side? This is A and this is B. Complement of A is outside of A. Yes, it's outside of A. Complement of B is outside of B. And A complement or B complement, it's union of, whereas we have of these lines or these lines. This is complement of A union complement of B. It's a bit messy. But as you can see, and these guys, also these guys. And as you can see, we get the same picture. But it's not a proof. It's not a proof. It's only explanation. If I want to explain your idea, probably it's good, but it's not mathematical proof. In our course, in mathematical course, not only in our course, also in stochastic processes and other mathematical courses, we need to prove things. And now let's prove this statement formally. Okay. Let me remove this. Okay. Ah, it's not here. It's here, yes. Okay. So how we can prove? We want to prove that the first step set equals to the second set. How we can prove in mathematics that two sets are equal? One useful tool, if we want to prove that two sets are equals, we can to prove that the first set is a subset of the second set, and the second set is a subset of the first set. If 1 and 2 holds, we can conclude when these two sets are equal. This is very known, very common mathematical tool to use. You know it? You remember it? Okay. So we will use this approach. We need to prove that the first set is a subset of the second set, and the second set is a subset of the first set. Okay. So let's start from step number 1. Suppose, let's take some element x with a general name, some element that belongs to the first set. Suppose x belongs to the complement of A intersection B. Our goal is to prove that if x belongs to the first set, that all x also belongs to the right set, to the second set. We want to prove that mathematically. And now you will see a proof. Pay attention. Proof is not very original. In this proof, we will use only definitions. Please help me. If x belongs to intersection of complement of A intersection B, then by definition of complement, what we can conclude, if x here...
It's not in the intersection of A and B.
Yes, this is definition of intersection. If x belongs to complement of A intersection B, then by definition of complement, x does not belong to A intersection B. It's not here. X is not member of this guy. Now we will use definition of intersection. If x does not belong to X intersection, how it can be possible? Why x is not here? Why x is not here? X does not belong to intersection A of B. The meaning is x is not the member of A, or x not member of B, or x not member not A, not B. So by definition of intersection, x does not belong to A, or x does not belong to B, or to both of them. Okay.
Why it can be in A, but it surely not be in B? If it's not in the intersection, it can be in A, but...
Yes, you see here O, not N.
Okay,
O,
I understand the
yes.
O. Okay.
Yes, O, yes. Okay. Now we use the definition of does not belong, or definition of complement. If x does not belong to A, then x belong
A complement.
to A complement. And similarly here. By definition of does not belong, we can conclude that x belongs to complement of A, or x belongs to complement of B, or both of them. And now we can use the definition of union. If x belongs to complement of A, or x belongs to complement of B, then x belongs to complement of A union complement of B. If x or here, then x is a member of union by definition of union. Look here. And this is the end of the first step of the proof. We assume that x belongs to left set, and the proof that in this case x belongs to the right set. And now we need to make something similar. We need to prove vice versa, vice direction. Please pay attention to this proof. You see, this is formal proof. We explain every step, and we get from assumption to conclusion. In your homework, if you get home a question and you need to prove something, try your best to write a formal proof. In formal proof, you need to explain what you do and why you do it, why it's correct. It's very, very important. You can only write answer. If the question is prove something, you need to explain in your proof every step. And our goal as teachers to teach you how to prove things formally. It's very important. I know for students from the bachelor degree, from the first degree, it's not easy to prove things formally. So one of our goals is to prepare you, to teach you how to prove formally mathematical statements and theorems. It's very important. It's hard. It's painful in the beginning, but it's very, very important.
Do you have a list? Sorry,
Yes.
do you have a list somewhere of all the different like things we can use to make a proof? Like, okay, there's definitions and there's other things.
Oh, good question. Okay. There are other okay, yes, good. Just a moment. Yes. Okay. This thing is very basic. It's from set theory. For example, in additional two definitions, you can use, you will talk about it afterward. You can use, for example, identities. Here the table of identities. Here the additional data. You can use it also. If you ask me, what are these identities? These identities from set course, from a discrete mathematics course. Yes, you can use it also. Okay, so this is a review of the things that you can use. Generally speaking, if you think what we can use and what we can't use, the thing that we will study in our course you can use, but in additional, you can use the things that you study in your calculus course, in your linear algebra course, in your discrete mathematics course, you can use it. Okay, but if you have any concern, can you use this statement or don't, you can ask us. Okay, let's return to yes, we were here. Any question about first direction of the proof? Okay, now we need to prove second direction, and it's very, very similar. Let me go to the end and let us check it. Okay, let us check the second direction. Suppose X belongs to the second set. X belongs to the union of A intersection of A intersection of. By definition of union, if X belongs to union, we can conclude that either X belongs to complement of A, either X belongs to complement of B. By definition of complement, we can conclude either X does not belong to A or X does not belong to B. But if X does not belong to A or X does not belong to B, by definition of intersection, X is not a member of A intersection B. But if X does not belong to A intersection B, we can conclude that X belongs to complement of A intersection B. And what we did just now, we prove that if X is a member of the right set, X must be the member of the left set. We prove both steps, both statements, and now we can conclude that first set equals to the second one. Complement of A intersection B equals to complement of A union of complement of B. Any questions? Okay. It looks familiar for you? A bit familiar? Yeah.
Yes, it's if and only if proof.
Yes, for set from discrete mathematics course. Yes. Okay. Pay attention. This is not tricky proof. We use only definitions of sets and of intersection, of union, of complement, and so. Okay. set identities. There are many, not million, but there are many set identities that you can use. For example, sum set union empty set equals same set. A intersection universal set equals A. A union A equals A intersection A equals A, complement of complemented A equals A. There are many of these rules. Some of them has names. For example, A union B equals B union A, commutative laws. Okay. Associative laws. What is important, what is very useful, not very useful, but useful, is De Morgan laws. Do you remember, do you know it, De Morgan laws? Yes. They are less obvious, but they also very useful. The main idea of De Morgan law, they give us connection between union and intersection. Complement of A union B, this set equals complement of A intersection complement of B, and vice versa. Okay, and there are many other tools. For example, A intersection A complement equals empty set. Pay attention, phi, or sometimes epsilon, they use it for empty set. Empty set. Empty set has 0 elements, it's empty. Okay. You can use these identities. They are not all identities that exist in the world, but for example, if you want, you can use this identity. And now I want to solve a few additional exercise, a simpler exercise in some sense. Let us prove this identity. Let us prove this identity. Here you have at least 2 ways how to prove this. You can use the same way that we use in example 1. Example 1. You can use the same solution, same idea. If x belongs to left set, then x will belong to right set. If x belongs to right set, you can prove that x belongs to left set. But it's longer solution. And we are lazy. In general, mathematicians are very lazy, so we want simpler solution. So I want to demonstrate you simple solution how to prove with equivalence, with equality. To prove this equality, we will use identities table. It's our good friend. It helps us to prove this identity in simpler way. So let's start. Let's try. Please help me. Okay, so as I said, we use identities for proving this equality. Okay, let's start. Let's start from this, from left guy, and our final goal is to get right guy. From left expression, we want to get right expression. So let's start from this fellow. Can you explain why this fellow left equality equals to right equality? What we did here?
We can use the Morgan law.
This is the Morgan, yeah. So we get from this fellow by the Morgan law. And okay, the Morgan is cool. We can use again the Morgan here. Yes? We can try. We don't know, but we can try. So let us use again the Morgan. Just a moment. Okay. So we use again the Morgan, and we get this fellow by the Morgan law. Okay. Look, please look. Okay. Now pay attention. We are here, and this is our final goal. What we can to do?
You can change the order.
Yes, we can change order here. Also, we can change order here. Why is that? We have some identity. Let's find it. Let's find it. We get identity that give us possibility to change the order. Yes, let's see. It's not here. It's here. A union B equals B union A. A intersection B equals B intersection A. It's commutative laws. Oh, we use it. Okay. So by commutative law, we can change here the order. So this expression equals to this expression. And now again, we use here commutative law. And we get, not here again, and we get final expression. What we did, we started from left expression. We use set identities in correct order, and we got right expression. So we prove equality. The morgam, yes, thank you. Again, please pay attention, friends. This is formal proof. In formal proof, we write a set of transition, and we explain every one of steps. Okay, it's very important. If you submit your homework, you need not only write formulas. No, it's not good. You need to write formulas and explanation. And our goal is to read your homework or your exam and understand that you understand your solution. It's very important. And to teach you better, to prepare better solutions. Okay. Question about example 2. It's clear? You can use reaction if it's clear. Okay, thank you. Please tell me when your next lesson start. In 2 and 15 minutes?
2 and 15 minutes.
Okay. In general, not today, but in general, our lesson is only 45 minutes. But today I want to do it a bit longer because I explain you how to use site, about LaTeX. Let's do additional exercise, okay? In general, it's 45 minutes, but today it's a bit longer. It's good for you, okay? Let us solve additional exercise. Okay. Here you can see a notion of intersection of infinitely many sets. Union, I goes from 1 to infinity, AI. This is infinite intersection. What does it mean? X belongs to infinite union if X belongs to to A1, or X belongs to A2, or X belongs to A3, or X belongs to A4 until infinity. X belongs to infinite intersection if X belongs to A1 and X belongs to A2 and X belongs to A3 until infinity. That's all. You know this sign, yes? Sigma. This is sum. Infinite sum. This is infinite union. This is infinite intersection. You know this sign? P. Infinite product. Okay. And now this is last exercise for today. Just a moment. I need to remove these 5 friends. Okay. Okay. Yes. Okay. Additional comment. In our slides, in my slides, usually I put more exercises when we can to do. For example, in class, we can do 3, 4 exercises, but I put here with solution 5, 7, sometimes 8 exercises. Additional exercises for you, if you want, but my advice to you to want, read additional exercises for slides, read their solution and understand them. And if you don't understand them, ask me, okay? So I always add additional exercises with solution for you. Okay. So now, for example, example 3 is for you. If you want, read it. And I want to prove with you last exercise for today. Exercise number 4. Okay? And I give you a hint. This exercise similar to one of equation in homework. So it can help you in homework. Okay. And this last thing for today. Okay. We want to prove the Morgan law, but not regular version of the Morgan law. We want to prove countable infinite version of the Morgan law. We want to prove this statement. Infinite intersection of Fi equals to complement of infinite union of Fi complement. This is similar to the Morgan, but it's more general. Okay, let us prove this statement. Here we have two sets, set 1 and set 2, and we will prove that set 1 is a subset of set 2, and set 2 is a subset of set 1. And now we will do only first step. Why we will do only first step? Because second step is very, very similar. You will see it. If you understand this transition, this proof, you will immediately understand this. Because it's very, very similar. It's not always the situation. Sometimes one step easier, the easy one, and the second is harder one. But in this question, both steps are very similar. Both proofs are very similar. Okay, we want to prove that the first set is a subset of the second set. And we will use definition, only definition. Let's take any element x omega, this is omega or w omega, that belongs to this guy. Omega belongs to infinite intersection of sets. By definition of intersection, what we can conclude? Omega is a member of
Each one of them.
each one of them. Yes, yes. By definition of intersection, omega belongs to every phi for all I. Yes. But if omega is a member of Fi, by definition of complement, omega does not belong to a Fi complement. Do you agree? If omega is a member of Fi, omega is not a member of Fi complement for any I. But if omega does not belong to Fi complement for any I, then omega does not belong to union of Fi complement. Yes, it's not a member of any Fi. So we can conclude it's not a member of union of them. Do you agree?
Yes.
But if omega does not belong to this fellow, to this set, omega belongs to complement of this set by definition of complement. Omega belongs to complement of this set. And we prove first direction. Every x that belongs to left set, every omega that belongs to left set is a member of right set. And in similar way, we can use proof second direction. And we conclude that infinite version of the Morgan law is correct. In your homework, you will do something similar. Pay attention when you write your proof. As I said, I repeated myself. It's very important not only submit formulas, also submit your explanation. Okay? It's very important. Okay, so we prove first direction. Just a moment. And here you can see the proof of the second direction. And from these both steps, we can conclude that these two sets are equal. Okay. In general, that's all for today. Before we stop, check what you can use this site. Try to understand how to use LaTeX. It's not very easy, but when you will study it, it will be easier, okay? If you need any help with LaTeX, try Google it. Try ask ChatGPT. And if you still to have any question, ask me by mail. Okay, thank you for today. If you have any question, I'm here, ask me. And thank you and good luck.
Yes, we will have an exercise for this week.
Yes. Every week. Our goal is to give you exercise every week. And you try your best to submit it, okay?
Okay, we need to do all of them, or there is like a 10 in 12 or something
Well,
like that.
Yes, okay. You don't need to submit every homework, but try your best to submit most of them, okay? You
Okay,
also don't
thank
need
you.
to solve any question. Try to solve as much questions as you can.
Okay, thank you.
But for example, if you have 12 weeks and you submit 9 homeworks, it's enough.
Okay, thank you.
But again, try your best to submit as much as you can. Okay.
Yes.
Okay. Additional questions?
Yeah, when are you posting them and when are they due?
When I post it, I hope I post it today or tomorrow. And in general, I give about 10 days to submit it. Why 10 days? If you have questions, you can ask me next lesson. Okay.
We
But
don't have a class
you will get
next-
just a moment. You will get announcement. Homework 1 published. Submission until this day, and you will see. And okay, question draw. Yes.
Yeah, we don't have a class next week, right? It's Hanukkah.
If it's a holiday, we don't have. Yes. I think yes.
Yeah.
If we don't have, we don't have. I don't remember exactly, but yes. If we have some holidays. Additional questions? Okay. Use my mail, and if you have question, ask me. Okay.
Thank you.
Thank you.
Thank you, Igor.
Thank you.
Bye bye.
Bye bye.